All right, we have speed networking now for all the developers in the audience. So if you want to talk about AI and robotics, head on over to the agenda to access that. And I am extremely excited about the next panel. Devin is back to chat with Rod Brooks of Robust AI and Clara Vu of Via Robotics about how robots can safely work alongside their human counterparts. They're going to tell us what's needed in hardware, software, and beyond. Please welcome Rod and Clara.
Hey, Clara and Rod, thank you for joining us here today. So I want to jump right into this with a more general question to set the stage. How do you think the idea or concept of collaborating with robots has changed over the last few years? We've seen this huge change to how people work and sensors and AI. How has this changed over the last couple of years? Maybe Clara, you can start us off.
Sure. Well, I think what we're starting to see is a lot more robotics and autonomous robotics showing up in a lot more places. And I think that contrary to the way some people might have imagined robotics would happen, where, oh, there's a lot more automation off in some room somewhere, more robots really means more robots in spaces where there also are people and more robots working with people. So actually, as robotic technology advances, we get a lot more human-robot interaction. And I think that's where we start talking about collaborative robots, because if we only automate the things that can be fully 100% automated in some back room, then we're actually automating a very small fraction of all the potentially valuable things to automate. So I think we're seeing a lot more of looking at, how can robots be in our everyday spaces or in our manufacturing or logistics spaces and work with people to ultimately get more stuff done, which is really what we want robots for.
And Riley, I'm sure you must have some thoughts on this as well.
Yeah, so, we've been working on collaborative robots for a long time. Claire and I worked together in the 90s at some point on robot toys that interacted with people was the first thing we worked on. And then there was the Roomba, which is a collaborative robot. You put it down, you press the button, although you can't have it totally autonomous, but then it interacts with people or avoids them, etc. I think almost anything interesting that happens with robots involve people. And although I deliberately do not work in autonomous vehicles, even autonomous driving, it's all about the people. That's where it is. And then on top of that, it's been around for a long time. We've been thinking about this, but processing and sensors and running deep learning models on narrow arithmetic architectures with teraops right next to cameras is really changing what you can, I wouldn't call it perceive, what you can label in the world. And with that labeling, you can build a lot more interesting behaviors which involve people in the loop. Up until recently, most robotics with people was just don't hit the person. But now it's much more interaction with the people.
Yeah, absolutely. And I'm curious, you sort of broached this topic. I'm curious how the hardware game has changed how you interact with the robotics as a software layer. When you have better sensors, faster and smaller chips that can do better object recognition, pass signals faster or to more robots, to more limbs, how does that change how you have to design or program or code your software layer? Maybe Clara, you can start with us there.
Sure. I mean, I think that we're kind of moving from this is not a term that I coined. This is something other people have been saying as well. But moving from sort of automation to autonomy. So from robotic systems that do exactly what they were told to do or can perceive a very specific, very low level thing, to systems that have a little bit more autonomy and understanding. And that doesn't mean they understand everything we understand or anywhere close, but just that they start to, as you're saying, sensing capabilities, processing capabilities, let those systems understand a little bit more. And so I think it's really, we're starting to see, use of more modern programming techniques and modern software capabilities being used in these ways. And certainly in our case, the system that my company builds would not have been possible 5 years ago because the sensors that we're using and the processors that we're using to crunch that data just didn't exist. So as we do have better sensors and more processing capabilities, we're able to, as you said, understand a little bit more about the world that we're in and sort of move the level of robotic performance up a notch. And that, of course, means that there's a lot more complicated software to go along with that.
Absolutely. And Rodney, of course, your new company, Robust AI, just listed the Veil on the new software and hardware platform. So in the first place, something that Clara mentioned sort of rang this bell in my head. You've got a no-code software platform. Why is that significant in a field where there's so much technical expertise and so much technical history and OSs? There's a lot of people out there coding. There's a lot of people out there who are very capable in this sector. So why does no code matter in a place like collaborative robotics?
We have lots of code. Our customers don't have to code. That's the difference.
Right.
Our customers, 80% of all warehouses in the US have zero automation, where a conveyor belt would count as automation. 80% don't even have that.
Wow.
So we're trying to put robots, intelligent robots in there. We're not gonna, we don't want to ask them to understand intelligent robots and programming and stuff when they've had zero automation, zero. So we got to make it easy for them. But that said, we, as a company building software for our robots, our software system is really complicated and makes use of those things that Clara was just talking about. I've been saying that we are in a golden age of computer architecture, because for since 1965, everyone had to code Moore's law. They knew, they had to make double the speed, double the memory, double this on this day, or otherwise their competitors would get them. So they couldn't do anything new and weird. With the end of Moore's law, they're now having to do new and weird stuff. And one of the big things is putting silicon right next to the sensor arrays and cameras. And on that silicon, running teraops with multiple neural models, recognizing particular objects, recognizing people, recognizing the configuration of people, what they're doing singly, what they're doing as groups. And in our case, where we have mobile robots in warehouses and cell-based factories, where there are people working, people aren't going away. This is to help them. The robots can be much more aware of people and what they're doing, keep out of their way when necessary, stay close to them when necessary. These are things we couldn't do 2 years ago. And it's because there's change in computer architecture.
Well,
and
let
then
me just
a whole different software system because it's at the edge.
Absolutely. No, I want to sort of double down on that really quickly before I come to you, Clara. You said so this wasn't possible 2 years ago. Maybe this particular architecture wasn't possible 2 years ago, but it's not as if we, have been hearing about, Kiva robots going around smashing people all the time. Obviously, the capability of avoiding people or, behaving somewhat intelligently in a warehouse has been around for a while. It just enabled so much automation. But so can you just tell me what you really mean by what was possible? What is actually possible now that wasn't 2 years ago? I saw you make that face. Don't think I didn't see that.
Yeah, I did make a face because it's nothing like what Kiva's done. Kiva's been great. It's been fantastic for Amazon, but it has relied on, you rip out everything and you build a new structure. So the Kiva robots, the stuff on the ground, they know exactly where they are. And they largely, Kiva robots, which is now Amazon, don't run into people because people and the robots are in different spaces. You partition the spaces. And that's what automation has been, partitioning people out of the spaces. And I know Clara's company is about having people near the robots. My company is about putting robots near the people that are already there doing their tasks, not getting rid of them, but providing assistance to them. So it's a different way of thinking about things. Traditional automation has really separated them.
Gotcha.
Yeah. In fact, as Rod was saying, the traditional Kivas, Amazon Robotics robots, the robots live in a giant cage in the center of the factory, and they don't allow people on the floor while the robots are moving. And I think what you're seeing is in the newer generation of logistics, for example, there's some other new companies like Six River and Locus in Boston as well. They're taking an approach to logistics that's actually much more collaborative, where you have people and robots in those same spaces. And as Rod mentioned, specifically for Veo, what my company is doing is, so far those collaborative techniques have relied on not having robots that are very, very dangerous. Essentially, they're small and they're weak enough that they really can't hurt you very badly, even if they tried. And that's ultimately the safety case that they rely on. So what we're working on is using those computer vision technologies to actually let robots that are very big and are very dangerous work safely with people using, again, sensing and vision in a way that is a little bit different because it has this functional safety component on top of it, which is another area that there's been a lot of new things happening in.
Right. I'm glad I picked the worst possible example and sabotaged my own question. But Clara, I wanted to hear from you. How do you agree with Rodney about how you need to actually deploy these robotics? Is there a need now more than before to be sort of a low code or no code? Deploy, like, the people that operate or are near the robotics don't need to be experts in that type of robot or encoding it or something. Is that more important now, or is that?
That is absolutely true. We also have a no-code deployment set up, and in our case, there's another layer on that, which is that, as I mentioned, we have a functional safety system, which means that you can't have people, coding on the fly, but you have a configuration that's locked in, and that's then proven to be safe. But I think the people that deploy, as Rod was saying, the logistics in many cases had very little to no automation. We are doing some deployment in logistics, but also in manufacturing, where there's been a lot of automation, but it's generally the systems integrators that are putting that automation together have an electrical or a mechanical engineering background. They're putting lots of different components together. And so you don't want to actually require those people to learn an entire another discipline to be able to deploy these tools. And I think really what that comes down to is the people who know how to deploy these robots, what they need the robot to do. They don't need to have expertise in the details of how the robot does what it does. You need to basically provide tools for the end users to, or the systems integrators, or depending on the industry, it might be a slightly different person, but provide tools for the people whose expertise is in the task, right? That to the task to be done, not the expertise in how to build a robot. Right. So I think those kind of very, intuitive interfaces, and we can use some of the same kinds of computer vision and graphics and the same technologies, that we use to make something autonomous, we can also use to give that system chunks of functionality that make sense and are usable by their deployers.
Yeah, exactly. Yeah, when I press the gas pedal in my car, I don't have to be a engineer to figure out, like, okay, the gas goes here, the spark plug does this. The car just goes, and it should be the same way with robotics. You're
going to decide left, right, slow, fast, but the car is going to figure out how to get there.
Yeah, that's the important part: left, right, slow, fast. That's how I learned to drive. So, Rod,
can I just add something to what Clara said? I always tell my engineers, the worst thing you can say is the end user can just, because you've already lost, right? 2 hours at iRobot. We put the Roomba out there, and if we said, the end user for the Roomba can just tell it where it has to go to recharge, can just do that. No, the end user is a consumer. I'm a consumer. I never read manuals when I buy something. I just want the thing to work. And that's what everyone expects now of automation. And so as we're putting it in factories or warehouses, we have to make it just work and not say the end user can just do X, or they can hire someone to do X for them, and then they can use our robot. Nah, we got to take what's there and just make it. It's got to just work. Otherwise, it won't get adopted.
No, I hear you. And Rod, let me ask you about this. It's been a few years since Rethink, and you've got a whole new company, a whole new approach. I just want to ask, since we're talking about these different approaches for training, for collaboration, now that you have a little perspective and time looking back on Rethink, do you think that you were too early to that side of the game, or was that not where the industry ultimately was heading? I'm just kind of interested in your sort of capsule thoughts on things looking back from now.
Well, first I have to say Clara's smarter than me, because I tried to get her to work. She was a consultant with Rethink, but she wouldn't join. She went and did something else, so she's smarter than me. Where were we? I refer to Rethink as a complete artistic success. It changed what people thought was possible, and other people are doing. You read what they say they're doing. It's exactly what we said we're doing, but we were too early in some sense, and we made a fatal error in not sticking with the original conception, which was to not put robots in places where robots already were, but to put them in other places. Because as soon as we went where they already were, there were expectations of what they should do, and that pulled us away from what our primary mission was. So lessons learned. It only took 10 years for me to learn the lesson, but I'm slow.
No, it's absolutely true. I think what you said, it did change how people think about it. And Clara, I'm interested in your perspective on this as well. Not asking you to do some kind of big analysis here, but as Rod said, you're the smart one in the room here. So I'm curious about your feelings on how Rethink sort of changed how people thought about collaborative robotics.
I think Rod is completely correct. The idea of collaborative robotics, as far as I don't know the entire history, but as far as I know, came out of Rethink. And that's just saying is, how could robots be different than they are? What could they do that they can't do today? And in particular, how could robots work with people, and how could that actually make the robots more valuable? And in fact, so my company, the idea for this company, my co-founder was at Rethink as well. And, it really came from, I was actually one of the angles. There are a lot of angles, but as Rod said, looking at places where robots already are, and looking at, okay, these, in many cases, cobots have, they've totally transformed the industry. There's I think 200,000 of them out there. It's growing at 30% a year. They've really changed. All the major robot manufacturers now make cobots as well. So then we're trying to really take the next step and say, what Rethink did, or the ideas behind Rethink has done for smaller, lighter weight robots, we want to do that for the big, powerful robots as well. And the way to do that is through computer vision. That's now, it wasn't possible 10 years ago to do the kinds of vision that we're doing now. And now it is possible, but I agree. I think that the really changing how manufacturing thinks about robotics and automation from something that happens, again, in a cage, completely automated, to something that where robots do parts of the work and humans do parts of the work. I think that's really the legacy of that company.
Absolutely. And as far as putting robots where they aren't, obviously, Rod, you mentioned this earlier as something that you're specifically avoiding, autonomous vehicles, but the kind of urban robotics or smart city type things that are, involving themselves with humans on sidewalks and in, university buildings and things like that, window washing, I don't know. There's all these new approaches, and they're all using some of the new sensors, the new miniaturized neural network type chips and all this kind of stuff. There's all these new capabilities, but how do you think that's going to play out? Is this kind of Cambrian explosion that's going to contract, or are we really going to see these become a normal feature of ordinary cities?
Yeah, I think we are. We shouldn't underestimate, for outdoor robots, how much you might have to change the environment. And I've criticized the autonomous vehicle companies for that. When we put cars in cities before, 100 years ago, we completely redesigned our cities. And I think to make autonomous vehicles really productive, we need to rebuild our cities somewhat for them. And we may need to rebuild our sidewalks for these delivery robots. We may need to change a bunch of things. And just putting a little bit of infrastructure in can make things radically easier outdoors. That's why my current company is all about indoors, because indoors, instead of a dynamic range in the light intensity of 10 to the 12th, which is outdoors, you only have 10 to the 6th, which is much easier to deal with. And there's less edge cases that randomly come into a warehouse or a factory. You don't have kids coming to tease the system, and delivery robots, it's a game. Tease them, have fun with them. You have to deal with that. In workplaces, it's a more controlled environment, and I think that's where we make progress for now. Later, we'll make progress elsewhere, but for now, those controlled environments, even though there's a lot of random stuff happening, are a lot easier to deal with.
Mm-hmm.
Yeah, I agree. I mean, I felt, you were talking about orders of magnitude in terms of light. I think that in robotics in general, robotics problems get exponentially more difficult the more uncontrolled the environment is and the more various the task is. So something that would be very simple in a single task in a fixed environment becomes, AI complete, as we like to call it, in an outdoor environment that's unstructured. And so it's not just a little bit harder. It's not just, well, you have this today and, in a couple of years you'll have that. It could be decades harder. And I think that especially I agree that the real automation can be so valuable in industrial structured environments right now, especially because often those industrial environments that's where the hard work is happening. That's where a lot of the big things are being moved and operations that humans can't do are happening. So not only is it more tractable, it's also in many cases more valuable to really be looking at. And it's interesting, in the Boston area, I've noticed 10 years ago or 20 years ago, there were a lot of people working on all kinds of different robots, home robots, personal robots, et cetera. Most of the Boston robotics companies now are working on industrial applications. And I don't know, Rod, are you bringing the gospel out to the West Coast now? But I wonder if we'll see it.
Yeah, there's some wacky stuff happening here.
Do you care to elaborate?
There's a lot of hype and a lot of overpromising, and it has been for autonomous vehicles or self-driving cars. The belief that we've seen one demonstration, so there'll be 1 million of them on the road next year, which we've heard again and again and again from one particular person. But lots of companies are just overhyping and misunderstanding what it takes to go from a successful demo to deployment at scale, especially in unstructured environments.
Right.
Scaling is always hard. Scaling takes a long time, and I think the companies that are really going after industrial and warehousing understand that. It's the companies that have just discovered that they can do something that looks smart and think, oh, scaling's no big deal. Because often in software, scaling hasn't been a big deal. But when you have physical stuff, the economics and the number of edge cases is totally different, and it's a different sort of problem.
Well, so let me ask you this. You mentioned, both of you have mentioned logistics and industries as being where the growth has to happen first. And I feel like we're probably going to see a few years of rapid growth in U.S. manufacturing, industry, and logistics to shore up sort of our end of the supply chain as all that's sort of failing and reinventing itself. What kind of opportunities do you expect for companies like yours? Clara, can you tell us, do you have a lot of inbound from people being like, wow, we're building 10 factories instead of 2 over the next decade?
Yeah, I mean, I think, we're seeing basically supply chain diversification. And I think for Veo, for a lot of people, this is sort of a new idea, I think. But for us, we're seeing an acceleration of a trend that's been there for quite a while, actually, to manufacturing needing to be, you can't just have one place that makes the thing. You have to be able to make the thing in a lot of different places, and you have to make different things. So that need for both productivity, which is very important in higher income, locations, and then also flexibility, that you don't know what's going to happen tomorrow. And those are both places where that, human robot collaboration, you get the flexibility and judgment and of people that can change what they're doing on a dime, and then you also get that productivity enhancement from robotics. So I think that those are trends that we were seeing already that are really accelerating because of a variety of global events that have made it really clear that we need to be more resilient on the supply chain side.
Yeah. Any thoughts on that?
I'll add to that. Clara was talking about the manufacturing supply chain, but the logistics in warehouses, you can't outsource that to some other country. It has to happen locally. And the trend we're seeing is people want shorter delivery times. And so the small warehouses in cities become more important. To get a 2-hour delivery time in a city, it can't be way out of the city, 100 miles away. It's got to, where it can be an enormous warehouse. It's got to be a small warehouse, and lots of them spread throughout the city, more specialized. And they don't have any automation right now. So that's why we're going after that. And then as we did that, cell-based manufacturing and other people say, hey, we can use exactly that solution. We have the same sorts of problems within our cell-based manufacturing facility. So yes, we're also riding on the tail of manufacturing back in the US, which, by the way, was the whole point of Rethink Robotics in 2008 when it was called Heartland Robotics. It was meant to reinvigorate the heartland of the US in terms of manufacturing. In that sense, we were a bit too early.
Ahead of the curve again. Well, let me just beyond logistics and manufacturing. We only have like a minute left here, so I just want to hear you talk about a little beyond those industries. Both of your companies now seem like they would be a perfect fit for some other things, like in hospitals, long-term care facilities, this kind of moving into that space where you have to take care around humans, but there is also huge benefit to automation or adding something in there to help with caregivers and stuff like that. Do you see your companies as entering those spaces anytime soon?
Let me just say, elder care in all its forms is an enormous growth industry across the planet because populations are getting older. I don't want to be too early on that one.
Right. But eventually. And Clara?
Yeah, I mean, we definitely have had some inquiries about, the applicability of our technology to, medical robotics, for example. Right now, I think there's enough in the industries that we're focusing on in, manufacturing and automotive and durable goods and consumer packaged goods and logistics. And that's actually a growth area for us as well. I can't see us changing that focus anytime soon. But I do think in the long run that these kinds of thinking hard about how people and robots work closely together, and in the case of a medical system, even more closely together than they would potentially in a factory. I think those are all long-term directions for this kind of technology for sure.
Absolutely. Well, glad to hear you say it. I'm looking forward to it. We are out of time. In fact, we're plus 40. But thank you very much for joining us. Your answers have been very helpful and insightful. Thanks again.
Thank you.
Thanks.